some of you might recognize me. I used to be an application engineer at NI in the Newbury office, which actually means that I taught quite a lot of different courses in the UK and also at some points in Europe. So yeah, maybe I have some familiar faces in the audience. I'm terribly sorry. For some reason, my keyboard doesn't want to update the slides. Okay, so like I previously said, so this presentation is a continuation on the presentation I gave at Dutlog. So there I talked more about, hey, how can you make your own application? What are the little things to watch out for? How does it actually work? Right now, I don't want to focus too much on that. Just for every one of you who has already watched that presentation to, well, not give you redundant information, fall asleep. Should at any point you haven't watched the presentation yet and should have any questions, please just tell me and I'll see what I can do for you. Maybe say, okay, let's leave it for after the presentation, or see if I can fit it within the slide I'm giving. So, like I previously said, so this presentation is mainly focused on, well, do-it-yourself applications. So how can you use an old phone that's just laying around and just place it somewhere for a little project you have within your home, and then put LabVIEW on it as an Android app or an iOS app, and then do whatever you want with it. So for example, here you have a little Raspberry Pi Pico with a Wi-Fi shield, which actually is going to be used within this presentation. So to provide I/O access. For industry-related items or industry-related topics, I would recommend visiting me at the GLA Summit, where I'll be talking about more industrial applications and industry-oriented topics instead of this more DIY, use-at-home solutions. So why embedded smartphone applications? Well, smartphones have been around for actually quite a while. So it started back in 1992. For those of you who want to feel old, that's even before I was born. Then during 2003, 2004, they started getting into a bit more of the mainstream with BlackBerry, Nokia, where you didn't just call and text, but you also had like little different apps that you could use, specific to BlackBerry, specific to Nokia, and so on. But it was getting out there. And then, of course, it became popular in 2007, 2009 with Apple and Android, two different ecosystems. But over the years, they've become pretty much the same thing. And of course, we don't speak about Windows Mobile. They don't exist anymore. But yeah. So, like I said, they've been around for quite a while. Now, I looked up in regard for this presentation what the average life cycle is for a phone. Now, the last couple of years, it's been elongating gradually over the 2 years, but it used to be less than 2 years. So, doing a little napkin mod, I calculated, okay, since 2009, 5 to 6 smartphones on average, some people more, some people less, which, well, it's just laying in your drawer. You say, oh, okay, screen is cracked, or the battery isn't what it used to be, or some of the camera has broken, or whatever. It doesn't mean it's no longer useful. So yeah, those that are laying in the drawer, no, they're actually, you can still use them. So one of the popular computers around for DIY is Raspberry Pi. I know there are more expensive variants, and then you can go cheaper with the Pico and stuff like that. But on average, I would say 40 euros. I do understand this is the Midlands LabVIEW user group, but I'm from Belgium, so I use euros, but I guess you all can do the translations or the conversions. But so a Raspberry Pi itself is 40 euros, which is fine. I mean, if you want to have a cheap computer to put somewhere in to control your curtains or whatever, great. But unfortunately, most of the times, that's not all you actually need. For example, if I would want to create something that's similar to, let's say, a phone, Then, well, I have the Raspberry Pi itself, which is a computer, but yeah, it needs a case because you don't want a bare bone PCB. Well, depending on what you want, you might want GPS and 4G if you want to have it somewhere in the field. Camera, screen, power bank, because this in itself has battery in it, so you could technically use it as a UPS. Speaker, microphone. Some phones even have more sensors or different sensors, more cameras. For example, I have here the Samsung 21 or S21. It has like 4 or 5 cameras which can work together with different optical points and whatnot. It suddenly becomes really expensive if you have to buy it new. But if you have a phone laying around, you can save quite a lot of money. Especially if you look at the sum, if you would want all of this, suddenly you're at 290 euros. That's a lot for just a quick DIY project. So hence, use that phone. Use that old phone laying around. Now, next up, I was thinking about, okay, what can I use this for? So I knew I was going to use my phone for a couple of different projects, which are in the pipeline that I want to do. But I want to give you guys something which touches all the bases, but still is quite easy to do even if you haven't soldered that much or anything. So I first started looking. So I like gardening. I have a ton of different plants which give me berries, nuts, citruses, a lot of different stuff, and I like to preserve them. So for example, instead of buying a really expensive food dryer, I could just say, okay, I have this inexpensive one where I just provide a temperature to say, okay, let me control it. Say this amount of time at this temperature, this amount of time at this temperature, and then stop. To control all of that via phone, maybe with a nice dashboard feature, possible. Or maybe, so I also do carpentry. I could, for example, have a table saw calibrator. So instead of manually setting my angle and my height, I could say, well, let me use a couple of servos, control them via a phone, that I have a nice dashboard that I can say, please put this to 12.5 degrees at 2.7 centimeters, which is also fun. However, I did not have the time to implement that, so I went for something else. Also had a look at a couple of other items or topics. Some of them already have apps in the App Store, so why make it yourself? But of course, yeah, have a look around. If you say, oh, these curtains, I want to automate them instead of pressing a button, well, have a look. Maybe you could use your phone. Well, the application I made in regards to this presentation is a greenhouse module. So like I previously said, I like plants. I love gardening, and I love collecting rare plants, edible plants preferably, or just uncommon ones. So for example, I have dragon fruit. I have, I think, 3 or 4 different banana trees. I have a ton of different citrus trees, lychee, pink pepper, and so on. And so these have quite a lot of things in common. They require the temperature to, well, not freeze, among other things. Also in the summer, they don't want to be too hot. So I did already a little bit of work. I had a lot of rain barrels. I filled them up with water, so to be a little bit of a thermal buffer. But still, this works during fall, during spring, but during the winter, yeah, this does not work. So I would want to see, okay, when do I need to start heating? When is frost getting into my greenhouse? So I need to start considering doing extra protection and all that good stuff. Not only that, I would want to know, okay, how much light is coming in? Once the days are becoming too dark, do I need to take that into account? Maybe if I put my plants somewhere else in a room or something like that, within my house, I have a couple of rooms where I can put plants. Is there still enough light for them to grow or just survive? And of course, also humidity and efficiency. So humidity, depending on that, my heating bill can go up, and also just efficiency. What's temperature outside, temperature inside? What's the temperature of my barrels? Are they still working efficiently? Do I need to add barrels? All that stuff. So yeah, I need an embedded application which can monitor these things, store them in a database, and maybe control some I/O. So I made this little setup. Now the fun thing about this is, I don't if not using it for commercial use, I don't have to pay anything in software licenses for this. And that's the fun part. So commercial use software licenses, okay, they're some headache. But when working at home, I don't want to pay €1,000 for a LabVIEW license or a specific driver or whatever. And I prefer to use community licenses. Same for servers, development environments, and so on. Of course, hardware is a little bit different, but yeah. So what's happening here is a little bit of the setup. Here we have my smartphone itself, which allows me to monitor the application or the setup, the greenhouse, and see, okay, how's everything performing? How's everything going over time? And even see pictures of, okay, this is what's happening at this point. All of this is stored in a WAMP server. This is something some of you might be familiar with. It's made by a team in France. And it's actually just an open source, or well, a free server that you can install on your Windows machine. And it has all this good stuff: Apache, PHP, MySQL, everything you need to, well, host some web pages, and of course, access, for example, databases. For example, here I use, within this example, I use PHP to access MySQL just so I don't have to put my SQL server on the internet, which some of you might know is considered really bad practice. Now, beside that, I have my embedded smartphone, which is actually the intelligence of my greenhouse. So that itself is constantly saying, okay, let me pull this data from the Raspberry Pi Pico, specific sensors or specific controls, and let me put that on the server. Not only that, like I've shown in the previous slides, the smartphone itself also has some sensors. So it already has a light sensor built in. Most phones have a light sensor here. For example, if you hold it against your head, then it knows, oh, okay, don't turn on the screen or don't trust any touch that you put on it. And also, I consider the camera to be a sensor. So I have a camera now in my greenhouse, which allows me to actually see what's going on. Did I forget to close the door, or are the plants still fine? So that's, like I said, I have a Raspberry Pi Pico, which communicates with the smartphone. And that has more that holds more of the low-level functionality. So I do have a couple of environment sensors. Sound fancy, but it's just the cheapest humidity and temperature sensors I could find. Same for a couple of soil and liquid temperature sensors. They're actually the same sensors. They're just waterproof temperature sensors that I could just place in the soil, place in the barrels to actually keep track of, okay, when is it getting too cold and when do I need to consider pulling everything out of my greenhouse in a more safe environment so that all my exotic plants don't freeze. Now, to give a more physical representation of that, well, here is a picture. So this is an old OnePlus phone that I had laying around where I accidentally messed up the touchscreen. So it wasn't broken, but it didn't register the touches that well anymore, but it's perfect for this type of application. And I also have a little Raspberry Pi Pico with some temperature sensors. You can see here little wires coming in, same here for the soil, just to keep track of everything. And then, of course, yeah, the phone app. So, for example, here you can see, oh, okay, I have my logging going on. I can see, okay, here during this time, the door was open. So whenever I'm moving my cursor around, I can see a picture associated with that specific measurement to see, okay, why did I receive that measurement? So temperatures were going low. Oh, it was dark. Or humidity was low. Oh, the door was open or closed when it shouldn't be. this is seen in the Android emulator. So this is, you could see it as a virtual machine. It's actually just a virtual machine running Android. On that, this is running as a native app. Again, to see how you would actually set that environment up and do that communication, I would recommend having a look at the .log presentation. So this is running as a native. Really struggling with this view. Okay, so the reason I'm running this as a native app is I want some of the functionality that a native app can provide. For example, I want this eventually to run in the background to give me notifications when frost has seeped into my greenhouse or just reached a specific temperature threshold, which tells me I need to undertake action to save my plants, or just to increase the efficiency or just make sure everything's safe. So the first thing you might have noticed if you followed the .log presentation was there was still an issue. So all of this is still based on WebVIs. By the way, this is all this is built in the new WebVI or GWeb environment, no longer in NXG, but it's exactly the same thing. They just rebranded the NXG environment. But so it's a web page, and we are showing that web page in our framework or Cordova framework. And web pages, well, you tend to be able to zoom in on them. If you show a normal app, you're not able to zoom, or you wouldn't want to zoom. It's just annoying when you are swiping and suddenly you get this pop-up saying, do you want to zoom in, or you accidentally zoom in when you don't want to. So how can we remove that? Well, for you fine people, I did some research, also as a nice extension, and this is completely new. You're the first people to see this. Well, first thing I looked at was, okay, can we do that in the in-app browser? So the in-app browser within our Cordova environment, can I disable zooming? Not entirely possible. There are some functions, but then I realized, well, there is already a solution, HTML5. And it's called Viewports, and it's actually already really common. I just completely forgot about it. But so a viewport, and that actually allows us to define the behavior of our web page in within a browser. So some of you might already play with this. So in G-Web modules, or G-Web VIs, you can actually alter the HTML codes by interesting. Like this, by just going up here, and you can actually edit the HTML source. So all we need to do here is say, okay, let's make sure that that the user can't scale it, and we're going to provide a maximum minimum scale so that the environment we're running this in isn't going to set the scale for us. When you set all of this, then suddenly that button goes away. You can't zoom in anymore. If you've chosen this correctly, you also can't pen anymore because you're within the bounds. And you get this nice app which feels completely native, that you don't really notice anymore that it's a web page. If you click buttons, if you're moving around, swiping, stuff like that, all of that works pretty nice. That's it for the phone app itself, so what's running on this machine. Like I said, a couple of things I'm still working on is notifications on environments. I will give a small demo at the end of this. Notifications on environments, but I didn't want to add it to this presentation because I've actually already shown that in the .log presentation, how to give your own little pop-ups. This is a screenshot from the YouTube video of that. Another item which I will need to add is run the app in backgrounds. I'm going in more depth into this when going to the embedded app. But it just means that the app is constantly running in the background, even if it's not open. The benefit of this is it keeps on pulling in data from the server to see, okay, did we hit freezing point or something like that. So that's, I can get my notifications even if the app is not open. And lastly, of course, port forwarding. So yeah, that I can go outside the house and still access my greenhouse. So probably with DDNS or something similar to it. Now let's get into the fun part of this presentation. So the embedded app. So this is going to be this is the actual app which allows you, well, that you put on your location or whatever you want to do, which is doing the actual computational tasks. Within my greenhouse monitor, like I've already shown, I'm taking images and I'm reading the light sensor within the app itself. So taking images, for those of you who have already played with it, is a little bit difficult within Cordova. So within Cordova, when you say, hey, I want to take an image, it actually gives you a pop-up. Again, this is shown in the Dotlight presentation. However, I found this neat package for Cordova, which actually allows you to programmatically control the camera so that you can say, I want to take an image. So instead of requesting an image and then pressing, OK, take it, it will do all of that for you, which enables me to take these periodic pictures to store them on disk or in the server. Same for reading light sensor. So here's just an NPM package, which, again, this is all described in the Dotlight presentation. But just by running this JavaScript code, you can actually get the value in lux of your intensity or light intensity sensor. This is pretty much the same thing as the accelerometer example or the battery indicator and stuff like that. So the embedded app, it has a couple of Cordova modules, but we can also leverage the benefits of LabVIEW modules. For example, the HTTP functions. Well, the the Raspberry Pi Micro communication, which uses that Wi-Fi shield, more on that in a bit. I can just communicate with that using HTTP GET commands to say, hey, can you give me all the data that you have? So I can then format it in such a way that I can send it to the server to be stored for remote access. So all these functions are readily available, nice and neat. So you don't even have to worry about that in your embedded application. One thing that I would want you to keep in mind is these Cordova applications, even though they behave like an app, technically they're still web pages. So make sure you have cross-origin scripting enabled within your servers. So so that's what I did with my Raspberry Pi Micro, where I have a little HTTP server running. I added the source code to allow to add the course header, and the same for my Apache server, which is running on an old laptop that I have laying around. I also enabled it there. Now, another thing I want to discuss with you when creating your embedded app is, well, what does it have to do? Is it just something you want to open, do a couple of things, close it? Then don't worry about this. Then this slide can go right past you. However, let's say you have an app and you want to run it in the background. It means that, well, I can open another app, maybe lock my smartphone so that it's still doing its task, but rather than someone else being able to touch the screen and mess around with stuff, it's nice and locked. It's great, but let's say I want to have a dashboard, something that's always open. Maybe you have your little spa outside, you have like a blow-up jacuzzi or maybe even a real jacuzzi or a hot tub, and you want to control the lighting and stuff like that. You can just use your old phone, keep it awake, and then you can constantly see what the status is and maybe change buttons. So keep awake, well, it's more the app constantly runs on top. If you accidentally close it, yeah, it's closed. I know I've written here, can't lock the screen. Well, you can, but it will pause the app. And I see this most of the time as something that can run as a dashboard. I do want to point out something I haven't done yet, but it is possible, is you can have a hybrid of these. So for example, you can have it running in the background, but when you want to have the dashboard enabled, you can enable keep awake. This is pretty much the same functionality as, for example, YouTube, where if I'm not watching a video, over time the screen will lock out and everything is locked. But I can still get notifications of new videos coming in. However, when I'm watching a video, I don't have to tap my screen every once in a while to make sure it doesn't close. So you can do something similar to that. Terribly sorry. I did notice that I forgot to add the hyperlink to that. And that's my mistake. But so, for example, to run it in background, again, like I discussed in like everything is just a plugin, a Cordova plugin that you can add. You just run the command to install it, and then you can just access the scripts, or you can control it using scripts. So say once background mode enabled, you just run this JavaScript within your application or within the Cordova application, and it's enabled, disabled, and so on. Same thing for the keep awake. During the example, I can zoom into it if everyone's interested, or if anyone's interested. Another thing I want you to consider when creating your own embedded app is performance. So LabVIEW is running, or LabVIEW Web Modules, I do want to say, is running on a stack of programming languages. So it's not directly communicating with the CPU. I know it seems logical, but I do want to address it. So every time that you go from one stack to another, or from one level to another, well, you lose performance due to abstraction. So for example, if I have a loop in LabVIEW, well, that's running multiple JavaScript commands, which in itself is running C commands, or well, DLLs, which in turn is running on the CPU. Most of the times, you don't need to worry about that. If stuff happens in 2 milliseconds instead of 1 millisecond, you won't notice it. Your user just won't notice it, and it's most of the times it doesn't tend to be that critical. However, for example, within the application or within the greenhouse monitor, I'm using base64 images. So I'm getting my images in, I'm encoding them in base64 to then send them to the server, which is just standard for web pages. But the issue is the base64 standard does have a couple of illegal strings for HTTP commands. So I need to escape them. The issue here becomes, well, it's quite a large string. So memory is not an issue, but I need to iterate through it and say, okay, whenever you encounter this string, escape it and keep on doing that. For one HD string, when doing that with LabVIEW Web Module as an app, it took me about 85 seconds, which is long, too long. I don't like that. I also written out how many iterations per second that is, just to give you an indicator that it's still quite fast. It's just the data is more. Again, this is a web module. This is not a C LabVIEW application running on a laptop or a dedicated machine. It's running separately. So yeah, try going to JavaScript. So if you run the JavaScript code instead, or if you run the function in JavaScript instead of in LabVIEW, you do have the benefit that it runs a lot faster. By going into, well, a lower level, it's more optimized. Yeah, best way to describe it is think of the LabVIEW performance course, where don't worry about it unless you encounter it, and then you can start thinking about, okay, instead of running this in LabVIEW, run it in JavaScript as a JavaScript dedicated function instead of a LabVIEW function which has for loops and stuff in it. which just means that it runs quicker, but it's just a bit more of programming overhead because you need to put in your hooks for the JavaScript function you want to call. Benefit of this function, for example, is this base64 function. Well, it's running. So if you run it as JavaScript, it's a single function. Well, if it's a single function, it means that it goes one level deeper. In this case, it will run on the DLLs which are underneath. This way of thinking, well, it counts for all scripting languages. So also in Python, MATLAB, for those of you who have worked with that, you also know, okay, try to push everything in as the least amount of functions as possible. It speeds up processing incredibly. And also, yeah, this improves user experience. Another thing for an embedded app, and I've already touched on this briefly, is I/O. So my phone is powerful. It has sensors. However, I can't put an LED on it or measure this temperature sensor. I can shove it into a USB port, but it's not going to do anything. So you need to communicate with some I/O. There's the same discussion going on with the difference between a Raspberry Pi and an Arduino. Raspberry Pi is a microcomputer, while an Arduino is just a microcontroller. The difference is one of them is running an operating system and can do higher level functions. The other one does lower level functions. Now, in this case, I'm playing around with a Raspberry Pi Pico due to some other projects that I have going on. But yeah, I also had a Wi-Fi shield that I bought with it just to play around with it. But yeah, you have different ways of communicating with that microcontroller, which controls your I/O, reads sensors, controls relays and stuff like that. For example, I have, so I'm using here a Raspberry Pi Pico. I bought this little wireless controller. I do want to point out prices have dropped quite a bit since 10 years ago, since the ones from 10 years ago for your Arduino and stuff like that. Those prices were insane. Here, more expensive is just you're paying for your Raspberry Pi and the shields, or your Raspberry Pi Pico and the shield. But the benefit of this system is your USB ports stay free. So something to consider is, let's say you have your phone. You can plug in USB, but the older ones, so USB-C does support communication and charging. However, for example, micro USB, the old ones, if you plugged in something to it, you couldn't charge your phone in the meantime. So running that embedded for hours or days on end is practically impossible. So if you use the Wi-Fi or Bluetooth or whatever standard you want to use, that stays nice and free. The other option you have is using USB. So the same thing with the Raspberry Pi Pico. You can use UART, so using USB for serial communication. You can plug that in directly to your phone, but for example, the reason why I'm not using that at this moment is just I don't have a hub or a USB-C hub, which allows me to charge my phone and in the meantime, run this microcontroller. This, of course, means that I would need to charge my phone every day or every 2 days, which I don't want to do for something that needs to run headache-free. Like I said, complications for powering the phone. However, so you can communicate with USB through your phone, or UART on your phone. So again, I know this is going to sound like a broken record at this point. There is a Cordova plugin for communication through serial ports. Now they call it Cordova Arduino. You can use this with an Arduino, but nothing is stopping you from using it with other devices, just a serial port. For example, if you have a bit scope, you could use it with dedicated hardware, or yeah, use it with an Arduino or maybe some knockoff thing, whatever you want, you could use it. This brings me to a couple of future improvements that I want to do. So, for example, live feed, which is currently impossible. Oh, well, not impossible. It's just currently not implemented. But again, because we now have this plugin, which allows me to constantly programmatically ask for new pictures or even streams or videos, I can actually accomplish this. Same for I/O control. So we're still early in the fall, so it's not really super necessary. Especially going towards the winter, controlling my growing lights and ventilation if the humidity becomes too high is something that is necessary. So I do already have a couple of these relay boards for other little projects, which I can reuse and control ventilation and growing lights with using the phone as the decision maker, or even that I can control it remotely. And another fun thing is just region of interest for plants. So it uses the base 64 images, maybe use a couple of JavaScript functions or libraries to take region of interests that are stored separately, so I can keep track of each different plant and see how they're doing over time. Okay, I'm going to wrap this up. So as a summary, what I try to have this monitor as a little bit of a guiding project for these new topics. So first of all, well, one of the things is the viewports. Now you can make your own applications in such a way that users are no longer complaining about zooming or accidental zooming or panning or the app not fitting nicely. You can now control this completely yourself. I've also discussed on keeping an app alive and how you could use it, different strategies you could use. And the LabVIEW Web Module performance, which is something that I feel more people should be aware of, that might be an issue when doing even little image processing. It's still something to consider. And well, the narrative for this presentation and the project is, well, don't hesitate to tailor make your own applications. You have LabVIEW knowledge, you can program everything yourself. The licenses are free. Well, nothing's stopping you to do it. Which also says, brings me to, well, don't waste your money. Yeah, instead of buying a Raspberry Pi and all this different hardware, just use your old phone. You can now program it in LabVIEW, so that's great. And just reuse your old electronics. Don't add to the e-waste. Reuse. Even if you don't have a phone anymore, or you throw them all away, there are plenty of old phones that you can still buy secondhand, or maybe someone has one laying around that they no longer use. Well, you can still reuse it. With this presentation, I want to thank you all for listening. Please visit me at the GLA Summit. There I'm going to talk more about industry items. Again, building further on what I've described at the .lab presentation. And before going to the code, for anyone that's interested, I do want to ask, does anyone have any questions? Open up the chat.
Thanks very much, Nathan. That was awesome. It's great to see what you've done there, because it's really accessible to quite a few people. As you were presenting, I was thinking about all of the old phones that I've got lying around that I can sort of try and chuck into this. But for me, just to kick the questions off, maybe I'm just trying to understand what was implemented where, and I think you showed a diagram that at the start of your presentation that kind of highlighted it. If you can go back to that, that'd be awesome. But I was just trying to get my head around it. That's it, yeah. So on the smartphone, both the smartphone application and the embedded smartphone, they're both developed using the LabVIEW Web Module.
Yeah, I can show that here. So this is running on a remote desktop. So here I have a little application for the phone, or for, well, my phone, my daily driver. But I also have my monitor application, which grabs the images and stuff like that. Do pardon the screen here. I am working on making this into a dashboard so that I can also keep track when I'm in the greenhouse itself to see what conditions are. But so this is running on the phone that's in the greenhouse, which is constantly pulling in data, taking images, taking light intensity, and then putting it on the server.
Yeah. Yeah, the bit on the server was done using Cordova, is that right?
So Cordova, as described in the .log presentation, is the framework in which we actually put these websites that we make using the web development toolkit and embed them into an APK or an iOS equivalent to put on your phone. The server running on running the database is WAMP server. Yeah.
Okay.
So
I'm gonna check. Definitely going to check that .log video out because I think that'll be. I didn't get a chance to have a look at that before this session, but that'll give some good sort of fundamentals by the sounds of it. So that'll be good.
So all in all, to give you an idea, to a little taste, I've already shared some code under .log. Okay, I could have actually better explained that before starting the presentation. But all in all, it just means that you have a bit of source code. All of this is built in HTML and Java. JavaScript and CSS. I provided a JavaScript file which does pretty much everything for you. So that the only thing that you need to do is place your application within this LabVIEW application folder, and it will automatically run the web page that you show in there as the app. And there are some hooks available to communicate with the framework to access different features of your phone, like camera and sensors and pop-ups and stuff like that.
Awesome. Cool. Has anyone else got any other questions?
Hi, it's me, Natan and Nathan. So thank you again for the presentation. It was quite nice. Just a quick question is, how long did it take for you to complete this? As in, how many weekends have you probably spent on getting this through? Question.
To get the initial thing running, I would say in actual work, I would say an afternoon, but I've worked on this on and off, 1 hour here, 2 hours there, stuff like that. But all in all, it's very low threshold, especially if once you know the little things about the Cordova application to run little scripts, which I can show here. If I go to diagram, for example, intensity service. So I do have a couple of description of that, or already have some documentation available with which to say, okay, run this piece of code in Cordova, and then make this little variable for intensity, which I am then writing in here, and then I can access. But also in .log, I also went a little bit deeper, and I described, okay, how can I send data to the framework using JavaScript, and also how can I command the framework to, once a certain event has occurred, how to get the data back. I've also, and I will share this code, I've also put that in here. That's a nice way to do it. But again, I'm constantly saying it, but I did go a lot deeper into that during the .log presentation, to go into little nuances of why I did every step that's in there.
Cool. Okay.
Thanks for your question.
Cool. Anyone else? Go on, sorry.
Yeah, sorry, Chris. It's Ray here. Hi, Nathan. Thank you for the presentation. What the sensors that you've used with the Pico Pi, are they? What did you need to do to configure the Pico? Are they I2C or are they just analog sensors that you can plug in?
So they're actually just standard sensors. I'm going to be quite honest with you. I went quite lazy with this. Let me pull away this. So what's actually, so they do have a digital component to it. However, the Pico has analog ports. So again, something that your phone doesn't have. Let me see, for some reason it's not, apparently it doesn't like my Bluetooth keyboard. Good to know. Let me pull something up. So with so all of this is done, or the Raspberry Pi Pico thing is done in Python, and yeah, most of it is just done based on the production code or the demo codes for that Wi-Fi shield. Just give me a second. It's opening up. For some reason, it's not responding. I'll change the share screen.
Okay.
But so, for example, these are different sensors I use. I use the DHT22 and the DS18B20, which are all just hobby sensors. So sensors that you can buy for a couple of quid here and there, and then when you order them, next day they're at home, and you can buy 100 of them if you want at the same time, and you wouldn't even have to explain to your wife why you bought them. They're so cheap. So all of these already have, because they're for hobbyists, they already have a ton of different example code available that you can just plug in into your Python code and use it directly.
Okay.
I do not know why this is failing. But no, don't worry about this. I will definitely share this code somewhere in the coming days for anyone that's interested.
Thank you. Yes, so I've seen the one-wire sensors, and yeah, it's great to see the Pico can support that. So you get very cheap sensing. Thank you.
Yeah, I do also want to point out that Pico natively supports this, so it's already part of the Python libraries.
Okay.
Anything else? Everyone's either speechless or bored out of their mind.
Oh, I can see Fred. Yes, there's a couple of questions in the chat there, Nathan.
Oh, sorry, I completely missed that. Okay.
Cool.
Is there? Yeah, so I will definitely share that. But I will also, so most of the Cordova resources or modules I use are already linked within the presentation, which is also going to be shared. But a nice thing about Cordova is, so I am a bit lost here. Here it is. When using remote systems, sometimes it's difficult to know where you're actually working. So when you have a mobile application, so when you place everything in here, you do have a plugins folder where you can actually see what you're using. So for example, my mobile application at this point isn't doing anything yet. I've yet to enable the background usage and stuff like that and pop-ups. However, for example, if I go to the monitor application, here you have a nice list of all the modules I'm using. So background mode, camera preview, plug-in device, light sensor, all that good stuff. Steve, does that answer your question? No news is good news. Okay, and Fred, so I will, so normally I put them on the forum, but of course, I think we can flash something out with the nice people which are organizing MLog in regards to where all of this is stored. But either way, I will make everything to a nice, neat little package which you can use and play around with to do your own thing with.
Awesome. I think a few people will appreciate that, Nathan. So nice one for that.
And next up, I can also give a quick demo if we still have the time. So the monitor application, I can't run that now because it's going to interfere with the same embedded application, which is running in the greenhouse, because then they're going to try and override each other in the server. However, I can quickly show, so again, this is also discussed in the .log. I do have to consider keyboard layouts. So when you run CMD, or when you run, if you open up CMD, you can just quickly tell the Cordova environment, okay, build me an application. Currently, I already have one built, so it's probably going to pop up straight away. But so I can give you guys now a little demo of, for example, how the emulator would work. So this emulator is a complete Android environment. It's literally a virtual machine, as if it's Linux running in Windows or Windows XP or Windows 7 using VirtualBox. This is just provided by Google. So also needs to boot up, unfortunately. Also, one of the things is this is running on quite a slow computer, so it might take a few moments. But it does give a nice representation of what this, for example, could mean to you. Otherwise, I need to show it on here, and that's a bit more difficult using using this live feed. In the meantime, does anyone have any other questions? If something pops into mind, feel free to ask me anything on LinkedIn, and I will be glad to help in any way I can. So either it's still loading or I accidentally broke it. Let's see. Now it's popping up. So, for example, yeah, this is not a live feed. It's still pulling in the data. You can see it doing that at the moment. This runs a lot quicker on my phone. I don't have virtualization enabled on this laptop, so it's running quite slow. However, yeah, for example, here you see a nice little feed. So it's still updating that. So here I have my different liquid sensors as described in the in the presentation, and then the setup. I have my humidity sensors and so on. And I do have all the functionality that I normally have, where I can navigate it. I can see the different values. And for example, here the app will then automatically update with the specific feed that was taken there. But this is running as natively. So if I now enable the background and just look at this data set, I could then, for example, say, okay, my phone should say, hey, I noticed the data that's coming in is worrying. Please, here's a notification. So yeah, that's that. And that's just a street light a bit further away.
So the Pico Pi is using your home Wi-Fi, right?
Yeah.
To
so,
connect to the internet.
Yeah. So I do have a mesh Wi-Fi network here. I just created a little guest network, which doesn't have access to the network, to the internet. I do have a nice little Cisco switch over here, which allows me to switch to different networks and connect them up. But yeah, just again, something to keep in mind. If you have something running as a dashboard and it's just laying around in your garden, make sure you lock everything up. Otherwise, someone could just come in and say, "Oh, this is a fun network. Let me just play around with it."
Yeah, I was just thinking about if you've got something deployed remotely, you could that's where you could use some form of sort of 4G device to do that bit.
Yeah, indeed. Here that would, so you would have that functionality. So for example, you could say, okay, go to cellular and stuff like that. And then on your phone, it automatically switches over. However, again, Cordova has a couple of hooks available to see, okay, or plugins available and to see, am I using cellular or Wi-Fi, and what's my Wi-Fi speed? And perhaps depending on that, you could put in some decision making. It's a complete environment. It's a complete ecosystem. So it's insane if I would now need to go through each different plugin. But if you can think of it, it's probably already done by someone to the point where even VR plugins are already available for Cordova. And if the plugin is available, you can do it within the LabVIEW Web Module.
Awesome.
So VR and AR.
I've got a further question, Nathan.
Yeah.
Where is the database located, and how much data are you storing? I don't know if you can say that daily or similar. It seems, I don't know how often you're taking the.
So currently I'm doing that. So currently I'm still gathering data to make decisions on how often do I actually need it. So that's going to change in the future. But it's running on this old computer. However, I do have a NAS here, which I am planning on using in the future. That's coming up, but I'm also thinking of just getting a rack-mounted thing. But depending on that, yeah, it's the amount of usage. It depends on what you want it to be. So if you want to have, so you can set the resolution of your camera, you can set the quality of your JPEG images. So playing with that, you can really reduce it or increase it as much as you want. And of course, how often are you taking an image? In this case, I can already tell you it's a lot.
Yeah.
Because I'm doing it every 10 seconds, just because I'm trying to gather data in general, just to make the best decision. But yeah, I don't really mind because it's my own system, so I don't worry about running out of space, because then I have to deal with it. If I would do this at my work, I would be more sensible about this and do a bit more research, but I'm at home, I just want to play.
Yes.
So for example here, yeah, the images, I can show the tables if you want. So the image is 2.3 gigs, and they're just base 64 images.
Yes.
I did provide some access points, so maybe in the future I can add a couple of different phones from different angles, or maybe some IP cameras or stuff like that, and I can just inject them also within this data set.
Right.
But yeah, so this is just a base 64 string directly put into it. Also, I'm Dutch, so that's why it's Dutch. But yeah, so I would say play around with it, but definitely have fun with it. It's a home project. You need to have fun with it. Don't go through it like you're at work.
No. I've done something similar, but not with LabVIEW in the past, and run out of memory because I was doing it locally, not on the Wi-Fi. It was too far away to be on the Wi-Fi.
Okay. I do want to point out. Let me see if I can find the correct plugin. I had it open just a moment ago. So this is that plugin, Cordova plugin camera preview, which is this alternate camera plugin that I discussed. And here you can actually control the width, the heights, and also if I can find it. I did notice my laptop is having issues lately, but normally I can. So you can set the quality, because this is a JPEG. You can decide how much information you actually lose. So this can go from 0 to 100.
Yes.
And playing with that, you can also save quite a bit. But I see these things as knobs and dials, and it's just playing around with it until you get that sweet spot of least amount of data and most amount of information that you want.
Okay, thank you.